Let's try an example of solving a system of linear equations using matrices. This time, 3 variables, 3 equations. I tried it myself. It got a bit complicated, and that's exactly the reason why I want us to try it. Okay, so let's construct the matrix. 2 minus 3, 4, 1, 5 minus 2, 3 minus 1, 7. And of course, the augmented part 8, 5, 22. We saw this in the last video, so I think we are familiar with the concept that we are talking about. The first thing I notice here, right, okay, and we are going to follow this sequence. So find the first pivot, make it 1. Now this is the first pivot, right, row 1, column 1. We want to make it 1, but I see an opportunity to make it 1 not by doing addition, subtractions or divisions, but just by exchanging these two rows. Okay. So this is what I am going to do. I am going to exchange R1 and R2. That just gets you introduced to switching positions of two equations. So that means we get 1, 5 minus 2, 5, 2 minus 3, 4, 8 goes here, and 3 minus 1, 7, and 22 stays here. We just exchanged row 1 and row 2. Okay. The next thing we do is make all elements in the same column of the pivot 1 equal to 0. That is, we need to 0 this out and 0 this out. So I will do R2 row 2 minus 2 row 1, and I will do R3 minus 3 row 1. Okay, let's see how that works out. Row 1 stays as it is. 1, 5 minus 2, 5, and this is 2 minus twice of 1, 0, minus 3 minus 2 times of 5, which is equal to minus 13, 4 minus 2 times of minus 2, which is equal to 8. And this row minus 3 times of this row. Okay, so 3 minus thrice of 1 is 0, minus 1 minus 3 times of 5 gives me minus 16, and 7 minus 3 times of minus 2 gives me 13. Okay, now I should have calculated this earlier. So this is 8 minus 2 times of 5, which is equal to minus 2. And 22 minus 3 times of 8 gives me minus 2. Sorry, 22 minus 3 times of 5 gives me 7. Very good. Okay. So we got these two. We got the first pivot equal to 1 and the remaining elements in the same column equal to zeros. Okay. Now let's look at what we can do. So we have to go to the second pivot now. The second pivot position is clearly this. Okay. Now I can actually divide this by minus 13. Okay. But let me try something else. Let me try R2 minus R3. This is just to demonstrate that there are multiple ways of reducing this matrix. We just need to adhere to the steps in the algorithm. So R1 stays as it is, 1, 5 minus 2, 5, R2 minus R3. Okay. 0 minus 0 equal to 0. Okay. Minus 13 minus of minus 16 would give me 3, and 8 minus of 13 would give me minus 5, and minus 2 minus of 7 would give me minus 9. R3 stays as is. Okay. I still got to get this to 1. Okay. So now I will divide this by 3. R2 divided by 3. Let me continue here. So R1 stays as is. R2, 0 divided by 3 is 0, 3 divided by 3 is 1, minus 5 divided by 3 is minus 5 by 3, and minus 9 divided by 3 is minus 3. R3 stays as it was. Minus 16, 13, 7. Let me just check what I have done here. Okay. Yeah, I think they are okay. Now, so I got my second pivot equal to 1. Okay. Now I have to zero out these guys, right? So look what I do. R1 minus 5 of R2 and R3 plus 16 of R2. So R1 changes now. 1 remains as it is because we have a 0 here. Minus 5 R2 gives me 0, and here I have minus 2 minus 5 of minus 5 by 3, which is minus 2 plus 25 by 3, which really gives me 19 by 3. Okay. And on this side I have 5 minus 5 of minus 3, right? 5 minus 5 of minus 3, which is equal to 20. Okay. R2 stays as it is, 0, 1, minus 5 by 3, minus 3. And R3 plus 16 of R2, so 0 plus 16 of 0 leaves this as 0, minus 16 plus 16 of 1 gives me 0, and then we have to do 13 plus 16 into minus 5 by 3, which is equal to 13 minus 80 by 3, which really is equal to 39 minus 80, which gives me minus 41 by 3. Minus 41 by 3. And on this side we have 7 plus 16 times of R2, that is minus 3. I think this is minus 39. Did I get that right? Oh, sorry, minus 41. So this would be minus 48 and 7, minus 41. That's where we are now. Let's go on. Let's see where we are. Okay. So we got our pivot 1 equal to 1, everything else in that column equal to 0. Pivot 2 equal to 1, everything in that column equal to 0. We have to address the third pivot position, and the way to make that 1 is R3 into minus 3 by 41. So here we go. The first row stays as it is. The second row stays as it is. In the third row, when you multiply this by minus 3 by 41, you are going to get 1. That's why we did it. And here we have minus 41 into minus 3 by 41, which is really 3. So we got the third pivot equal to 1. Now we just need to zero these out. And the way to do that is R1 minus 19 upon 3 R3 and R2 plus 5 upon 3 R3. Let's go here. So R1, look, these two positions of R1 are not going to be impacted because we have zeros here, and that's the way this thing is designed. So this really stays 1, 0, and this we have set it up such that this will 0 out. 19 by 3 minus 19 by 3 into 1, so this becomes 0. Okay, the same. Okay, let's calculate the augmented part. So the augmented part will be 20 minus 19 by 3 into 3, which is equal to 1. So the augmented part becomes 1 there. R2 plus 5 by 3 R3, right? So R2. The same thing here. Notice these two are 0, so these will not be affected. And this we set it up to become 1. So minus 5 by 3 plus 1 into 5 by 3 will become 0. We really need to worry about this part. So minus 3 plus 5 by 3 into R3 into 3, which is equal to minus 3 plus 5, which is equal to 2. And R3, of course, we are not changing R3, so it stays as it was. Now, what this really means is we have come to a point where 1 0 0 0 1 0 0 0 1. Remember to get the variables back. X, Y, Z equal to 1 2 3, and that really means that x plus 0 plus 0, x plus 0 plus 0, 0 plus y plus 0. I'm just using what we have learnt in matrix multiplication, and the third one now. 0 plus 0 plus z, 0 plus 0 plus z equal to 1 2 3. If you compare these elements of these two equal matrices, you get x equal to 1, y equal to 2, z equal to 3. So we believe this is the solution to these equations. Let's quickly substitute 1, 2, 3 in these equations and see if that's correct. Okay, so the first one, 2 into x, which is 1, minus 3 into y, which is 2, plus 4 into 3, which is z, that equals to 2 minus 6 plus 12, which is 8. So we are okay with the first one. Let's look at the second one. X, which is 1, plus 5 into y, which is 2, minus 2 into z, which is 3, is equal to 1 plus 10 minus 6, which is 5, which is 5. So that's okay. And the third one, 3 into x, which is 1, minus y, which is 2, plus 7 into z, which is 3, is equal to 3 minus 2 plus 21, which is equal to 22. So I think we got the correct solution. I just wanted one example of, 3 equations and 3 variables you saw, and we'll do some more examples because some points about the elimination, the rules, the way you do it may not just come out by doing a couple of examples. We'll do a couple of more examples, and then I think we should be comfortable with elimination. Thank you.